Hello, my name is Marc Reagan. I'm going to talk to you today about the basics of human spaceflight operations. My background is I've worked at NASA for about 27 years as an aerospace engineer, and all of that time has been spent in mission operations. I was a space shuttle instructor for a while. Then I was a space station training lead, and then I have worked in mission control for the space station for about the last 15 years. So my whole career has been spent in operations. So let's talk about that. At the highest level of making human spaceflight happen, we have three dominant areas. And you can think of these as operations, which we'll talk more about here today, but also there's a whole engineering piece of the apparatus, and there's the science. The whole reason we are doing this is to go do some kind of science, presumably. So those are the three big, highest level areas when we talk about spaceflight. So operations I'll define as achieving the mission objectives. Whatever those objectives are, operations are how we get that done. The engineering are the people who ensure that the spacecraft and the ground systems can support the mission. And then the science, of course, is informing the primary mission objectives by describing why are we going there in the first place? What are we there to do? So let's take the operations piece of that now, and we'll break it into several parts. First, we have an infrastructure which allows these operations to happen and has to be operated itself. So you can see in these pictures here, I have a picture of a tracking data and relay satellite, which we use to relay communications between low Earth orbiting spacecraft and the ground. So that's a piece of infrastructure. It's part of how we allow commands and communication and telemetry to go back and forth between mission control centers and spacecraft. And also a big part of our infrastructure are the ground-based systems that allow that too. So we have space-based systems like this satellite I'm showing you, this communication satellite, and then in the picture below that we have a picture of the ground-based antennae that are communicating with the spacecraft. So those are just part of, for like the space shuttle or for the space station, these human operations, those are part of the basic infrastructure that just allow us to do the operations of the spacecraft that have the humans on it. Then we have another category, which is the launch piece, the ability to launch these spacecraft in the first place. You see a picture here of a shuttle launching, but everything but that shuttle is part of the infrastructure, is part of the launch-based operations. So it is assembling the rockets, it is testing all of the rocketry, it's loading them with their fuels and their propellants, it's getting them out to a launch pad, and it's the launch pad itself. It's all of that, making sure that we have a launch operation that can happen as well. But of course, launch operations and the infrastructure I talked about earlier are things that support all kinds of space flight, not just human operations. So don't forget that those things are out there, and don't forget that those things have to be operated. But what I came here to focus on today is the flight part of human spaceflight operations. That's the part that's very unique, that we do very uniquely when there are humans involved. So on the flight side, you see a picture of a space shuttle in orbit. You see a picture of two astronauts doing a spacewalk or an extravehicular activity, or EVA, on the space station there. So this, how we operate in flight, is the part we're going to focus on now. So on the next slide, we're going to break down flight operations a little bit more. And you can think of flight operations as having three key parts. First is the planning, next is training, and last is flying. Plan, train, fly is how we think of spaceflight operations at NASA. So in the pictures there you see an example of a plan that has the timeline for the day. You see some training happening in our big swimming pool where we train for spacewalks, and you see an astronaut in space actually working. Let's talk more about the planning piece of this now. So planning consists of building the executable plan for the crew and for the Mission Control Center teams. You shouldn't think of it as just something that the crew is doing. You should think of it instead as a orchestrated symphony of activities from mission control teams across the world. That's what's really happening in modern human spaceflight. Is we have multiple control centers, we have multiple operators in those different control centers, as well as the crew on board, and all of them have to work together seamlessly every day. So the plan is an integrated executable list of activities that includes what the crew needs to do every day, and it includes what the Mission Control Center teams are doing every day, their activities. It also takes into consideration a lot of external things that need to be factored in for the plan every day. For instance, environmental considerations like pointing, which direction the spacecraft is pointing in, and that might matter because it matters what the lighting is going to be like on different parts of the spacecraft. Especially in that picture we saw a minute ago, those guys are doing a spacewalk. Well, the lighting is very important so that they can see their workspace, their work site as they're doing that spacewalk. And of course, as you orbit the Earth, you go from light into darkness, back to light, and so those spacewalks are put together with a very intentional plan, considering where the light is going to be, or when the light is going to be there, and when it's going to be too shadowed or dark to do work. There are thermal considerations. These are huge in space flight, and certainly huge in the human space flight vehicles we have to date. So those also get impacted. The thermal condition of the spacecraft gets very much impacted by the light and darkness cycles as well, and which direction it's pointing in, what things are getting direct sunlight or getting hot. But we have radiators to dump that heat, so where those radiators are able to point away from the sun to colder, darker parts of space allows them to dump heat. So thermal considerations are very much a thing that one has to plan around in human spaceflight. And then there are trajectory considerations. A good example of that is we have a periodic, we have thousands, even tens of thousands of pieces of junk in space that are a danger to a human spacecraft. And occasionally orbits intersect and it becomes a problem, it becomes a risk to the space station, for instance, that a piece of this junk could hit it. And if it hit it, it could be catastrophic. It could, at the very least, cause the structure to depressurize. And so we're tracking these tens of thousands of pieces of space debris that are out there at all times, and we are predicting when the orbit of a piece of junk might become a concern, might coincide or come too close to the orbit of the spacecraft that has the people on it. And if that happens, if two pieces are predicted to get too close together, something's got to move, and the piece of junk isn't going to move. Its trajectory is very much described by the orbit that it's in. So what has to move is the space station in this case. We actually do little reboosts or trajectory little small burns that change the trajectory so that the orbits no longer coincide. Those happen periodically with the space station. So trajectory concerns, that's one example of why we consider those, but trajectory concerns are very much part of the plan as well for operations. And then, so once you've considered all of those environmental things that are going on, and you've considered the work that you're trying to get done today, then you can start focusing on how do we get the work done. And ultimately, we get the work done by giving the workers direction that makes sense to them, right? We call those procedures. And again, the workers are not just the crew on board the spacecraft. The workers can conceivably be scattered across the world in different control centers, as well as the crew on the spacecraft. So the way we do this is we have a timeline like the one you see here, and it's got all these considerations on it that we talked about. But on any given activity for any given responsible party to go do, you can click on that activity and it'll pull up a link to the procedure that that person needs to go execute, and it'll say things like execute the whole procedure or execute step 1 through 5 or whatever is appropriate for that task that's being done. And then one step further, one step deeper, as you think about the planning function of operations, is, wow, that must be a lot of procedures, right? Must be hundreds of procedures or thousands of procedures, and you would be right to think that it's thousands of procedures. And so now you have a problem just in all the procedures, in managing all of those procedures and the configuration management over time to make sure that those procedures really are correct, and even the steps that we're calling out are correct for what we're trying to do. So I hope I've given you in this some appreciation for different aspects of the planning. As we go to the next slide, you have to also consider the fact that it's not just these procedures, but it's the tools that allow you to see the procedures. And it's not just building the timeline, but it's the tools that allow you to view the timeline wherever you are. So building and maintaining these tools that allow for all of that, and the tools to allow all the different players in the timeline each day to make their inputs for the plan, that's part of the planning function as well. And then finally, these planners that we have, in the world of the International Space Station, where we have 5 primary mission control centers, multiple science sites around the world, and crew members from multiple different space agencies coexisting at one time, what you see is that you have lots and lots of activities all day long on the plan that all need to be coordinated. What's going on in that activity needs to be coordinated with the responsible party, with the activity owner, to know what the procedure to call out and what steps and what constraints they have, so that that can be built into the timeline at a place where it will work. But now you cross across all of the systems owners, all of the systems that need to be operated on board the spacecraft that day, all of the systems that need to be operated across the whole ground support infrastructure that day, and all of the objectives you have, like the different science experiments that you're trying to put together that day. All of this is happening across all of the different international partners, nerve centers, mission control centers. So the planning function now is a lot more than just what you see in this picture on this slide, just a picture of a plan that a few crew members are doing that day. Planning function, you can see, is goes very deep and has lots and lots of people involved and has lots and lots of activities and constraints that have to be balanced against each other every day in order to make a plan that's executable, that's actually going to work. I'll leave you with one thought on the planning, and this is really true across human spaceflight. If you've put the effort and time into making a plan that is really executable, you've done 90% of the work. Actually, executing each activity on the plan is a very small piece of work. It just takes an hour to go execute an hour activity on the timeline. But it may have taken months or days or many, many hours to hammer flat all of the different details that were involved in making sure that that activity was ready to execute in just an hour's time. So the planning part of the process is really the place where a mission's success is decided. If you've got good planning and you've put all the effort into coordinating and integrating a plan that's executable, the actual execution is fairly simple to do. Let's go talk about the second piece now. We talked about plan, train, fly. Let's talk about the training function. So training consists of preparing the mission operators, which again are the ground operators and the crew, for both the planned activities that are on the plan each day, but also contingency activities or emergency activities or not expected activities that might come up. So training has, once again, by itself, has three separate pieces. There is a training management function. There's the lesson conduct, actually performing the training for the students. And then there is making sure we have the facilities that we do the training in. So let's talk about the training management function briefly. Training management is you can think of that as the planning piece of the training function. So we have, just like we have plans to execute in the space flight itself, we also have plans of how the training is going to happen that we execute. So if you look at this graphic here on this slide, you see a few different people. These bands represent 3 different space station crews. These are real. I grabbed these just the other day of 3 different crews we have in training right now for space station missions. And what you see here is some colors that represent the country that they're going to be in. So the yellow represents that those guys are going to be in Russia during that week of that month of the year. The blue and the yellows have an R in them to represent Russia. The blue A's represent that they'll be in the United States, represent America. The green E's represent ESA, the European Space Agency. That's actually in Germany is where they do those. And the purplish J's represent the Japanese Space Agency. So those happen in Japan. And then the white V's are vacation weeks for those crew members. So you can see now that every week is planned for every crew member, for every astronaut or cosmonaut that's in training at a time. And you can see that a given crew isn't even necessarily in the same country on a given week. And they're certainly not necessarily training together on a given week, but there are weeks where they're lined up and they're all training together with one another. Finally, at the end of all that, in red, you see an L, and that's the launch week. That's the week their mission actually starts. So the planning of all of the training that they do is also quite complicated and takes inputs from all of the different training centers across the world, and we figure out where these astronauts and cosmonauts need to be so that they can get that training. It's a little bit simpler for the ground teams. The ground teams are primarily training in their own country, so they can take that training where they live, and we don't have to have such complicated integrated schedules for them. But suffice it to say that the training plan is also a very complicated and integrated product and has lots of people working together across the different training centers in the world to try to make it come together and make sure our crew members are prepared. Another function of the training management is standards. You want to make sure that as you go from lesson to lesson, the content is at the same level, and it's at the right level, that it's at the level that the student really needs, not too deep because it'll take too long to train them if it's a bunch of stuff they don't need to know, but obviously not too shallow either because you need them to be able to do their job from the training they get. So finding the right level of content and the right standards is an important function of the training function. And if you think that starts to sound like a lot of work, then multiply it times all of the different places this training is happening. It's not good enough for NASA to come up with standards and try to police those standards for training, because we have people, as you see, training in different places all over the world. So trying to make the training standards uniform and consistent across the world is, as you might imagine, a very big job as well. Let's go from training management now to lesson conduct. This is the heart of a training program. This is where the training actually happens. And so when you think about what it takes to make the training actually happen, you're going to realize that developing these lessons is a part of that. They don't just spring up automatically out of the ground. Somebody has to go and develop these lessons, and they have to apply the standards that we talked about and make sure they're at the right level of detail, and they have to be appropriate to some kind of facility. The lesson may be as simple as an instructor in front of a classroom with a PowerPoint presentation. That's a really easy one, but that doesn't get you very far. Typically, for any given system, like the thermal control system, say, there's at most one lecture with PowerPoint on how the thermal control system on the space station works. From there, you start going into facilities that are a little bit more flight-like and a lot more complex. And you start actually performing procedures and working with simulators, and so making sure these lessons are both appropriate in content and appropriate for the facility along the way is a piece of that. Then you also, in the lesson conduct, if you're going to have an instructor teach a lesson, you need that instructor to be certified, right? How could you have a lesson that's at a uniformly consistent level if you didn't have some standards for the people teaching those lessons? So not only is the content of the lesson policed by standards, but the quality of the instructors is policed by making sure that they go through a certification flow and get certified to teach those lessons. And then finally, there's the oversight of the execution. The way this lesson conduct works is you don't just have one person teach each lesson, because at the end of that, any student would be left trying to fit all those different pieces together in their own head. What we end up doing instead is you go from individual lessons where you're learning how systems work, for instance, to more complex lessons where lots of systems are working together. And then with lots of systems working together, you add your other crew members. Now it's lots of people working together with all the systems working together. And then you add the mission control team, or maybe all of the mission control teams. And as these lessons progress in complexity, they they become more complicated facilities required, simulators that are very complex with multiple systems running at a time, and the capability to tie in control centers around the world. And so the complexity keeps growing, and you need somebody that can just be in charge of that can oversee the execution. It's just able to lead all of the people involved and all of the requirements involved, and make sure that all of these lessons are progressing such that the students are being trained appropriately as they get more and more complex. So the training leadership piece is required. And then finally, on the next slide, there's a facilities function we talked about. And the facilities function requires identification of requirements. So what the facilities need to be able to do. Somebody needs to come up with that, right? Somebody needs to go build the facilities accordingly, programmers usually. And then instructors who know how these facilities how they want the facilities to work, need to go in and test them and take delivery of them and make sure that the simulators we use at whatever level of complexity they are doing what we need them to do in order to train with them. So that's the testing and delivery piece. And then finally, flight software is always changing on board. Our understanding of how systems work evolves as we operate them in space. And so over time, and things don't work appropriately. We took delivery without everything working because we had to. And so there's a piece of this that's a maintenance and improvement piece that's ongoing to continue to improve the facilities, to accommodate changes in software or hardware on board, and also just to take advantage of the fact that we've learned how things work better after we've operated them for years than we did at first. So some examples of facilities include just classroom lessons like I'm giving now, to part task trainers. And the two pictures that you see here on this slide, one of these is a part task trainer which just has a crew laptop and a simulator that simulates one system at a time. So for instance, he can simulate the attitude control system and see the warnings come up as something goes wrong, and execute a procedure and send commands through the laptop, and really learn that one system in this kind of environment. And before he gets to an environment where he has to integrate a bunch of different systems working together. The picture on the right is of a training session with some spacewalk hardware. It's kind of a hands-on session, piece by piece. That's similar to a classroom session. On the next slide, we'll see a few more examples. On the left is a facility that's basically a gravity offset system that we use on occasion. It's a harness that's connected to some motors on the ceiling, and the motors are very quick response, and if you push off in any direction, the motors will continue that kind of velocity that you've incurred until you reach the limits of your workspace. So what it does is it gives you an environment very much like zero gravity, where any kind of reactive force you put into the system causes an equal but opposite reaction on your body, and it's really a good place to learn how to work in microgravity, learn how to use tools, because as you apply forces with tools, you're going to be pushed in the opposite direction. It's a good place to learn that. The picture in the center is of a virtual reality piece of our training facilities. You can see that person on a virtual reality headset, and he's reaching for something that you can't see, but he's basically doing a spacewalk. He's in a simulated spacewalk, and it knows where his hands and gloves are, and he's able to go through a whole scenario tied in with someone else in a simulator fashion in that virtual reality environment. And then the picture on the right is again a picture in the pool of spacewalk training. You can see all the people that are not in the white spacesuits are support divers, helping make sure that to the astronauts shown, everything is appearing like it would in space. They're managing the umbilicals and making sure the tools are where they ought to be so that the training astronauts can have the experience that's flight-like. On the next slide, you see some examples of more complex simulators now. On the left is a space shuttle simulator, which is no longer in use, but you can see that this is a cockpit that is very similar to the space shuttles. It's all of the switches and panels and sizing is just like the space shuttle. The only thing that's really different is instead of windows to look outside, you have monitors where computer-generated graphics are filling the space. Down in the center you see an instructor station. This is a place where a team of instructors is running a complex simulation with a mission control team in the control center somewhere, with the crew members inside the crew station of the simulator, and these instructors are designing and putting in the case for the day for a large multi-$1,000 per hour simulation. And then on the far right you see our complex of modules that represent the space station. That's where we do a lot of the space station crew and flight controller training, is inside those modules, which are very high fidelity. On the next slide, a few more examples. We also have aircraft operations, because flying aircraft, especially with multi-person crews like you have in those small trainers you see in that picture, cause you to learn how to work together and follow procedures and think very quickly on your feet. So aircraft, we found, are a good supplemental training kind of environment. It's not spaceflight training per se, but it's how to be an astronaut training, how to think like and react like an astronaut with other crew members training. And then the two pictures on the right come from our spaceflight analogs. These two pictures come from an analog we do under the sea, but it's also a place where crew members learn how to live and work together, how to execute timelines and execute procedures, and basically how to be good astronauts and good crew members before they finally get assigned to space. Alright, last piece of this that I'd like to look at today is the flight part. If the planning part was 90% of the work to a successful human spaceflight operation, the training part is about 8% of the work, and the last 2% is actually flying and doing it in flight. By the time you've successfully planned and by the time you've successfully trained, actually doing it in flight is the easiest part of it. It's also, comparatively the part that takes the least amount of time, because all the heavy lifting happened in those first two phases. So the flying is the real-time operations required to fly the mission, and it consists of monitoring and operating the spacecraft systems. It consists of getting the work done on board the spacecraft by the crew, and it's ensuring that all the operators are working together across the mission control centers around the world and inside the mission control centers around the world. So you see a couple of pictures here of mission control centers. The top one was from a picture taken during a moon landing, and the bottom one is in Houston. International Space Station's control center on a recent day. That's a modern day picture there. And basically, every day they come in the flight phase and execute the plan. And that's what the flight phase is. It's making sure that each of the activities on the plan gets executed, or if we run into problems and we can't, it gets kicked back into the planning process and we figure out what went wrong and how to get it back on the plan another day, and how to go execute it another day. The flying part, again, is easy if you've done due diligence on the planning and training part. So, hopefully with this you have seen you have a good idea now of the different components that make up human spaceflight operations. One last thought for you. Don't think of this as happening in an order like I presented it. You don't plan one day, train other days, and fly the last day of this process. All of these things are actually happening all the time. We're planning for days or weeks or months or years to come. In fact, all of those. We're planning for all of those. We're planning for tomorrow, and we're planning for things that are coming years from now in different parts of the planning process. But that's happening all the time. We are training for crew members that are going to fly months or years from now, and we're training multiple crews that are launching at different times, at staggered times. And so the training is ongoing and continuous as well. And finally, the flying is happening, at least in the space station era, the flying is happening every day. Crew members are always on board. We're always executing 365 days a year. We are executing in space station operations. So the planning and the training and the flying you can think of as all three happening all the time in order to support the human spaceflight operations that are ongoing. So thank you for your attention. I hope you learned something here, and hope you enjoyed this experience.